Hi everyone, and welcome to our video on graphing tangent and cotangent functions. So the tangent and cotangent functions are also periodic, just like sine and cosine. They do repeat themselves forever, so from negative infinity to infinity, but they repeat themselves every pi. So the most basic tangent graph will look something like this, where it has an asymptote, vertical asymptote, and our period goes to pi. So the asymptote's at pi halves. Okay, so that and then 0. And that is our most basic tangent curve. And this is one period of it. If we wanted to, we could make a table to really see it all. But I'm going to skip it. If you want to try it yourself, you can start to get these points and see that it will make the same sketch. Okay, one other thing about tangent is sometimes they like to see one full period involved, or I mean one full branch involved. So I'm going to put this in the blue over to the left in case they want that. Here's the other asymptote that would be at negative pi half. So it's this and this are the same but opposites. Okay, so the blue branch to this black branch in between the asymptotes is one period. So is this in the black ink from there to there. Okay, so currently graphed is 1.5 periods. Okay, so it just depends on what they might want. The reason I like what I did in the black ink is it continues the process of graphing a sine and cosine function. Okay, so the next one, the most basic cotangent function, always has an asymptote at x equals 0 and then x equals pi. And it starts up high and goes through the midpoint of those asymptotes and then keeps going down. So this midpoint would be at pi over 2. Okay, and just like before, we can make a table if we really want to take our time to see it, but we usually like to go a little quicker now. So if we're going in order of the videos, the sines and cosines functions that we graphed have a similar process to these, just the shapes are going to change. So our most basic form, so our A is no longer an amplitude, but it's still important. So I would say we'd want to set that equal to something. Our B tells us how to get the period. And on our tangent or cotangent, the period is pi over B. Okay, so not 2 pi like sine and cosine, just pi. And then cotangent has the same information. So whatever A is, and then B is still pi over, oops, that's the period, pi over B, like that. Okay, so we can find those, we can find the period using that B value. All right, and then still I would think about it. Let's draw again, real quick sketch. Tangent starts off something like that with an asymptote in the middle, and then goes back to the x-axis. And then cotangent always has the asymptote and then heads down with the midpoint and the other asymptote. Okay, so those are just, again, very, very quick sketch. But both of these still do the half-half times 3 technique that I used with sine and cosine. Okay, so the half-half times 3, I'm still using that. Okay, so let's see these two non-shifted graphs. So we have y equals 6 tangent of 3x. And we'll find the period and the phase shift, and then we'll graph it. So our a value here is 6. And then our b value is 3, which means our period is pi, again, just pi over b. Let's write the whole thing down this time. But b is 3, so we'll change it to be pi over 3. Okay, so that's the period. Notice there's no pluses or minuses, so that means the phase shift would be 0. So they did ask for it. Let's go ahead and just box it too. So that's nice. We don't have to really worry about it. Okay, and then now that we have that information, I'm going to do the half-half times 3 scenario. Okay, so I'm instantly, let's put our asymptote somewhere right in the middle of the x-axis to the right. And then starting at 0, 0, so tangent starts at 0, 0, then it goes up to the asymptote. And then we pick up again on the right of the asymptote down below and bring it up to the x-intercept. Okay, and the A was positive, so it does match the same direction as our tangent graph that we had above. Okay, and then now we'll label our values on the x-axis. So the period should go to pi thirds. And then half half times 3. So halving pi thirds would be to times the denominator by 2. Okay, so that would be pi over 6. And then often that might get in the way, so we put in, and this makes it the official asymptote as well. So they might ask, so that's vertical asymptote. So they might ask for that anyway. So I'm going to go and box it. Okay, so that can clean it up in there. So there's half. And then let's half it again. So that means still times the denominator by 2. So that would be pi over 12. That's where that 6 would come in to this problem. And then if we times that by 3, we would get 3 pi over 12. And I'm putting a pi because that reduces. So this simplifies to be pi over 4. And that's where the negative 6 would be. Okay, so the 3 pi over 12, that was scratch work. I am just going to scratch it out. You could erase it. Okay, but those are our important 5x values, and then so I'm putting 0 there again. Okay, so we still have, so here's 1, 2, 3, 4, 5 x values that are important, just like it was with sine and cosine. Okay, so that was one full period. If I want to, we can double check. So I'm going to check this point that I'm marking in purple, which would be pi 12ths and 6. So I want to see if that works in our equation. So we have y equals 6, tangent of 3 times pi 12ths. Well, 3 times pi 12ths simplifies. That's 6 times tangent of pi quarters. Tangent of pi quarters we can do, that is 1. And 6 times 1 is 6. Yep, Okay, and still, you can still use your unit circle. Pi quarters is here. And then the tangent would be to divide those two coordinates with each other. So the y divided by x, and they're the same, so that means it's 1. So that's how we can evaluate them still. Okay, so that is our sketch. Now let's see. Let's do one other thing actually to it. So again, just in case if they said, oh, we want to see one full branch of the tangent curve, then we would, I'm going to put this in blue, and take our asymptote, there it was, and draw in a vertical line for the vertical asymptote. And my purple's kind of in the way. Let me erase my purple that's there. There we go. And we can still find this vertical asymptote, which would be the opposite of the positive one that we already had. Okay, that way, again, from the blue to the black right here is still one period, just seeing it a different way. All right, so just to add to it, just in case we need it. So just like sines and cosines, if we need more information, we could usually find it without too much effort. This one, though, again, I broke it down trying to do the sine and cosine process. All right, so let's see this cotangent one also in this video. So we've got our a value is -4. That's where I would mark something near it to say we will reflect. And then our b value is the value that's attached to x there. So we have b is 2/5, which means our period, let's go that way with it. Our period, again, is pi divided by whatever that b is. And then now let's multiply both the top and bottom by 5. And then when we do that, we'll have 5 pi left over on the top. The 5's down below cancel, and then we're left with 2. Okay, so our period is 5 pi divided by 2. Like the first one, there's no pluses and minuses, so that means the phase shift is also 0. So I'm just going to put that right here in case they did want it. There we go, we boxed it. They said it in the problem, but it's really not super important. because there is none, so still 0. All right, so there's our information for our cotangent. Now again, I'm going to set this up. All right, so cotangent, I'm going to draw in the asymptotes. Let me do those in purple. So it starts at x equals 0, and then I'm going to draw another asymptote somewhere to the right. So we've got x equals, and that would be the length of the period, so 5 pi over 2. And then in the middle is where the cotangent curve should cross. Now cotangent, I'm doing it dotted. Cotangent should look like that, but ours is reflected. So ours should be from down below. Mirror image of that dashed line. So it's kind of like the DNA helix type of picture. Oh, that's bad. Remember seeing those? Okay, so get rid of those horizontal lines. But anyway, let me cross that out. Not super important. All right, but that's what it looks like. So the solid one is almost the final cotangent curve. Let's continue with our half times 3. Okay, so 5 pi halves, I would need to half, which is really multiplying the denominator by 2. There we go, 5 pi over 4. And then we would need to half that again, which is still multiplying the denominator by 2. Okay, so that dotted line's a little in the way. Let me erase. Ooh, that's not erasing. Let me erase part of that so I can fit it in. So multiplying the denominator by 2 gives us 5 pi over 8. So that's the tick mark there. I'm putting up a high because I couldn't fit it down below. But that is where the -4 on the y-axis would match up. And then if we half it again, or not half it again, if we times it by 3, what we just found, times the numerator by 3, again, I'm going to erase that a little bit. If we times the numerator by 3, we would get 15 pi over 8. And when we match it up with the curve, that's where the +4 would be. And then let's mark our origin 0. Okay, and just to highlight our 5 important x coordinates, here they all are, right there, well, the asymptote. So there's everything. So there's the sketch. Just like before, we can still double check. So if I plug 5 pi 8s in, so -4 cotangent 2/5 times 5 pi 8's a little tight there. Okay, but these 5's cancel. 2 and 8 reduce to give us a 4 down in the denominator. So -4 cotangent of pi quarters. Well, cotangent of pi quarters is the same as tangent of pi quarters. It's also 1. And then -4 times 1, yeah, that matches that point right there. So when we plugged in 5 pi 8s, we did get -4. Okay, so that's how we can graph these. Okay, so I'm going to put a pause on it. The next ones are shifted ones, but if we remember again, sine and cosine, to be a broken record, it's just like those where we'll do arithmetic. Okay, so if you did want to try them before looking, give it a shot. Okay, other than that, thanks for watching, and I'll see you again next time.